Hey, everybody, welcome to the first live edition of the Rust Review podcast. I'm Brandon Conkle, and this channel, Deterministic, is where I explore different approaches to embrace more determinism in our programming and avoid the chaos that plagues us day to day in our modern production environments. Today, I am joined by Alex Keliris. He is someone I've worked with for a while now, 3 years now, or coming up on that, through Formidable on different clients. And I've definitely loved his refreshing perspective on things. He's actually a big part of the reason that I got into Rust. So welcome, Alex. I'd love to have you say a little bit more about yourself.
Thanks, Brent. I actually didn't know that I had some influence in your your coming to Rust. So yeah, I've been using Rust since about 2017. I originally got into Rust after, like many people, mostly using Node in production and running into constant bugs. At the time, I was using Sentry, and it was just full of errors all the time. And it occurred to me that so at the time I started using Flow, then TypeScript, but a proper good type system that, for example, that Rust offers just attracted me so much, because you can remove so many errors at compile time, and that's what I find most interesting about Rust. The performance that you get, I feel, is like an amazing benefit after that, but definitely the correctness and runtime safety is what motivates me so much, and why I love Rust.
Oh yeah, I 100% agree there. I came to Rust through TypeScript originally, like you're talking about, or Node in that environment. Earlier on, I was a Python developer, but I went through Haskell and OCaml and PureScript, some of the ways to bring more soundness to types in the JavaScript world. And Rust is kind of a completely different approach to solving the same problems in a unique and really fantastic way. And I agree that the performance it's secondary to me. The performance is what makes it so compelling, but the maintainability, I think, is really the key value proposition there.
Definitely.
So kicking off our Rust review today, we're going to cover articles, about 8 different articles over the last couple of weeks in the Rust community, and kind of talk about why we found them interesting, point out some things from them. We'll link to all of the articles in the show notes later on. First off, let me go ahead and shift to our first article, Why Rust? So this article is written by Emil Emmerfeldt. He's the creator of eGUI, or eGUI. I don't know the right way to pronounce that, but it's the friendly UI library, he calls it. It's a UI library for cross-platform apps that can run in the web and natively. And he's also worked with physics simulations, games, 3D scanning, cybersecurity, etc. He's the founder of Rerun, a company that makes visualization tooling for computer vision and robotics. And so he's working with some really cool stuff. He's got a lot of experience. His background is heavily C++, which is more the low-level domain that Rust fits in. But he's also done a lot of work in the higher-level languages like Python and Lua, and has been a developer for more than 20 years. So I definitely respect his opinion here. So the article here jumps into his reasoning about why he picks Rust, why he's so enthusiastic about it. And he starts off his post with a pretty bold declaration. He says that, "I believe Rust is the most important development in system programming languages since C," which that's huge. But I've heard a lot of similar sentiments in the community like that, like talking about adding Rust to the Linux kernel and things like that.
I think it's interesting there that he says Rust is not a particularly original language. So a lot of the advances Rust has made they're not original to Rust, but the language is as this article will go on to say, things like the package manager, everything about the language, the tooling around it it's quite revolutionary, and I agree with that statement.
Yeah, it's not like a particular killer feature or something like that. Although I think arguably the borrow checker is kind of a killer feature, but it's not the only thing that makes it great. It's this collection
Definitely.
of amazing features that work together.
Yeah.
Yeah, it definitely came together in an amazing way. So he goes on to talk about safety and speed first, even though that's not the core problem. But he talks about how safety, he qualifies it talking about memory safety. So handling array bounds checks, data races, use after freeze, seg faults, the kind of things that really plague low-level languages like C and C++. But then when you go into the higher level languages like Python, Lisp, Java, etc., they're safer, but they're all a lot slower. And so it's a bigger trade-off. You had to think about the trade-off pretty thoroughly based on your use case to decide whether, C or C++ or a higher level language was right for you. And Rust kind of gives you the best of both worlds. He was saying that the common wisdom was that it could be either fast or safe, but not both. And now we have both. So that's pretty exciting.
Yeah.
Going into the borrow checker, I've talked about my appreciation for the borrow checker before, and how it really makes you be more comprehensive in how you're approaching ownership, how you're approaching references and how those references are used, and mutability and things like that. He describes it as arguably the most important innovation. Wait, no. Didn't he already say that? He did. He described the borrow checker in much the same way. Most important innovation in system programming languages since C. But basically, he talks about how newcomers often have trouble with it because it prevents things that are really common in other language ecosystems. Like Go allows async concurrency really loosely without worrying about ownership and multi-threading. And those are things that you have to worry about in Rust, but that's part of what makes it more sound, I think. And then enums. This is a big thing that I loved from the Haskell and OCaml ecosystems that I've worked in before, where it's more than just a simple specifier of a type or a case or something. You can actually add additional data to your enum variants, making them really powerful for pattern matching. And this is one thing that's really hurt me in Go. The pattern matching in Go is really rudimentary and it's non-exhaustive. So if you add a new enum variant and you don't handle it, Go's not going to tell you about it, but Rust absolutely will.
Yeah, I'd say the enum as an abstraction is so powerful. I love. It's probably that alongside the borrow checker is probably one of my favorite features of Rust. Like the results options, they're all enums ultimately, and we all know how great option and result is for modeling the states of your application. It's just a really, like you say, it's really painful in Go not being able to reach for an enum.
Yeah. And kind of like in our current project, we're kind of making kludgy solutions around enums to try to backfill support for them, but it's really loose. It's weak.
Yeah, it's clumsy.
So Douglas Carrera has chimed in to kind of support the same point we're talking about, with that Rust attracts more developers because you can write code that is as safe as the higher level languages with a lot of the tooling and syntax features and things like that. So we can be more comfortable writing low level code now. And that really is the amazing thing, I think, about Rust.
Certainly for me, I don't consider myself a systems programmer as such. Like, I'm not writing embedded code all the time. I'm mostly writing web servers. The reason I love Rust is because, I might not feel like I'm writing low level code, but actually I'm writing code that has very little, there's no cost to the abstraction, so-called zero cost abstractions that Rust boasts about. So I feel like I'm writing high level code, and then I get amazing performance.
Yes. Yeah. And he also mentions the ergonomics that come from functional languages. And this is something that kind of threw me off, because functional programming in Rust doesn't look like functional programming in other contexts. Like the point free style of Haskell is very different. This feels more imperative, but it still supports a lot of the functional paradigms that you come to expect.
Yeah, like we have closures, we can pass functions as parameters. we have mutability by default. Immutability. So it's a nice mix. Well, we don't have to reach for abstractions like the monad, for example, but we can get the same level of safety writing slightly more imperative code, but maybe that's easier to understand.
Don't get me started on monads. I'm one of the people that took a long time trying to find a good explanation, because they say once you understand a monad, you can never explain it. But I felt like I found a way, but there's no reason to go that complicated. You're right. So, and the next thing he mentions is the error handling, which is another thing that I love about Rust. The question mark syntax for bubbling up the error variant on the result or on the result enum.
I love that syntax sugar.
It's so much more developer friendly, I feel like, than returning errors like in Go. And with Go, you always have to have a secondary return position or return argument reserved for an error that really gets in the way a lot. And the question mark syntax sugar in Rust kind of abstracts that all away in a really clean way. I've seen people using it for other things too, for setting rejections in warp and things like that. Not necessarily just errors, but converting it into other things. All right. And then he goes on and he talks about scoping and WebAssembly. I've talked about WebAssembly before on the podcast, and it's really opening up some exciting possibilities. The traits are awesome, enabling polymorphism in a really controlled way. And he talks about the difference between compile time polymorphism and runtime polymorphism, and how Rust supports both, using dynamic dispatch for the runtime. And then talks about Cargo and Rust Analyzer, which are outstanding. I definitely love the tooling around Rust. It feels even better than some of the tooling that I've loved in the TypeScript world. That was one of the strengths of TypeScript, but Rust is approaching that here. And then he does call out some of the bad here. It's not simple. It's definitely harder to learn. It's got a lot of syntax that's tricky to get used to. Yeah. There are tricky type errors, and especially when it comes to like multi-threading issues, when you start getting errors about things needing to be copy or clone, implementing those traits, or sync or things like that. It's definitely tricky at times.
Yeah, I 100%. It's not all rainbows. I think for me, lifetimes, I often will get stuck with lifetimes when I want to store a reference to something in a struct, for example, and then I'll have problems working with that. The amount of syntax it can be
things like the turbo fish.
Yeah, not super easy to read, especially like if you're reading library code. Like we might look at it in a minute, like Axum, for example, the way they implement things, it's hard to know what's going on with generic bounds. But for the amount of power it gives you, I guess it's kind of an inescapable cost, maybe.
Yeah, nothing is free, I guess. Everything comes with trade-offs. One of the things I think Go really does have over Rust is compile times. Like the Go compile times are blazing fast. It's amazing how quickly it's able to run through it. And Rust will sometimes take a few minutes on a large project, or I've heard people with really large projects talking about 20, 30-minute compile times. So that's definitely a trade-off.
Absolutely. That's something I found really refreshing working. And our Go project is somewhat large now, I'd say. And yeah, like I've got another Rust project, my Spotify TUI project. I think that's 10,000 lines, and it's not super slow to compile. It feels like compiling a game. But yeah, it's nice to have such quick feedback. Like live reloading feels kind of like what I'm used to from Node when I'm using Go. But with Rust, like I use Cargo Watch all the time, but it still feels slow.
There's a delay, yeah.
Yeah.
It kind of feels like the early days of Next.js, where sometimes it would take 30 seconds, 45 seconds, sometimes even a minute to recompile in response to a hot reload or something. But yeah, I feel like the trade-off is worth it. The soundness, the safety, both memory safety and just having the strict and sound type system preventing you from runtime errors, it's worth it.
And certainly, like compiling for release, which does take a long time. So, like when you're compiling for a Docker image or something, that does take forever. But then you're getting a ton of optimizations and just incredible performance at the cost of that compile time, which is, for a release build, it's kind of okay because we're not releasing like every 2 minutes. Maybe some people are, but
that would be amazing. I've seen the continuous deployment setups, but I've not worked in a really good setup like that before, where really you could have deployments every few minutes if you really wanted to.
Yeah,
I know it's possible though.
Yeah.
All right, so I'll move on to the next article I wanted to pull up here. I've been watching the Rust Reddit a lot, and it can be hit or miss. There's a lot of random stuff that gets posted there, but there's a lot of interesting discussion there too. And this one kind of really piqued my interest because we're working on a Go project full time right now, and I'm doing a lot of Rust on my side projects at the same time, and so I get a really sharp contrast between the two environments. So the original poster here, pardon me, but posted a couple of weeks ago asking about resources for porting from Go to Rust. He's got a moderately large Golang project that he wants to rewrite in Rust. So he's buying into the meme, rewrite it in Rust. He says he'd consider himself intermediate. Some of the nuances are kind of opaque. He's wondering kind of how do you translate from some of the Go idioms to Rust idioms. And the discussion that ensues, I think, is really good, and it has some interesting points. First off, there's some talk about some of the equivalents in Rust, and I think Tokyo is the right choice for the async runtime because it does feel similar to Go routines, although it's a little more visible. It's kind of abstracted behind the scenes in Go.
Yeah, I think that's something I do really like about Go is that the concurrency is so first class.
Yeah,
it's such a great feature of the language that you don't have to think about awaiting something. You don't have to think about concurrency at all, really, when you're writing a web server anyway.
Yeah, I know there's some cases where we've used defer and things like that, but for the most part, it's really invisible.
Yeah.
He talks about channel equivalents. So Tokyo has an MPSC channel library. I've also heard of Crossbeam as an alternative to provide channels. That one of the articles I covered on a previous issue said that they vastly preferred Crossbeam.
Interesting. I've used the built-in standard library channels and the Tokyo channels, and I find them really pretty great, really easy to use. There's a little bit of boilerplate because you have to spawn a thread, send something in, clone it, and so there's a little bit to think about. But once it's set up, it's fantastic.
Yeah, and yeah, channels is a great way to implement, I guess, a cross-thread communication.
Yeah.
In fact, I think a lot of Go's approach is centered on channels for inter-process communication like that.
So, for example, in my Spotify project, there's the main loop that is rendering text to the terminal, and then I need to also handle asynchronous requests to the Spotify API. And yeah, you can see a little demo of what it looks like there. So I have to be able to send a message to another thread to perform the request and then send it back into the main render loop so I don't interrupt that and I get 60 FPS. Obviously,
nice.
In JavaScript, in Node, the browser is implementing the event loop for us. But in Rust, I've sort of built my own event loop with operating system threads and sending messages. But it makes for a super clean, like the state is, a lot of my state management is in the type system, which is the dream.
Yes. Yeah, totally agreed. The next one is interesting. Let's see. Oh yeah, no, I already mentioned the Crossbeam. So a lot of the comments in here though are actually discouraging rewriting in Rust. And I get it because we do have a tendency to gravitate towards the new hotness, whatever's getting the most buzz, whatever's most exciting. But we sometimes neglect the massive amount of effort that's involved in a replatforming. So the advice that a lot of people gave was, don't do it. Seriously, don't do it. But then they go on to say, okay, if you do it, figure out exactly why and what it's going to benefit you. So enumerate the problems very specifically, identify why Rust will solve those problems, and make sure to take the time to figure out if the effort is going to be worth it based on the benefit that it'll provide. And I think in a lot of cases, people might use the new hotness to try to attract a wider talent pool, but I think that is a risky move. That's something where that talent pool might be fickle, it might move on, and then you'll be left with something that it's hard to find people to work on. What if the Rust becomes old news and the new hotness is something else entirely? So you definitely need to use caution.
Because in that Why Rust article we were looking at a minute ago, they mention in there, I think, that it's been a good decision for hiring. One of the answers to Why Rust is because it does attract a certain quality type of developer. So that's interesting. But yeah,
that's true.
Right,
but that's somewhat time dependent, I think, because we're in this moment where Rust is just entering the Linux kernel. It's becoming more widely used everywhere. Now, I think it's going to stand the test of time. I think that it's going to be around for a long time and will become the de facto replacement for C++. But there's a chance that it won't. Like I've been at places that hired really hard for the Python Django framework because they thought that it would attract a really wide talent pool, and it did for the first few years. But then that started to cool down, and we started to see Node and TypeScript start to dominate. So it's a risky move. It's really hard to take something large and complex that's already working and port it over to any other platform. Whether that's Rust or something else. Rust is no exception there, but I think the particular benefits of Rust add some weight to that decision where, it might be worth it to rewrite, but it's certainly easier to start with Rust Greenfield.
Yeah, I think like in the famous Discord example where they had a lot of Go, I can't remember what feature of Discord that they had a lot this big Go code base to support this feature. And they were seeing, they started observing the garbage collector taking up memory, and they could just see the sawtooth pattern. And then they rewrote it in Rust, and it was just flat, really low resource usage. Like that's a well-motivated reason, kind of high-stakes rewrite. But
that's especially compelling, I think, for TypeScript, and I think Go also, because you don't really get a facility to manually control garbage collection in Go, do you?
No, not that maybe there's some low-level APIs, but not really. At least not idiomatically, importantly.
Yeah.
Because you could go in and maybe do some crazy optimizations, but then it's much less maintainable. Whereas you can write idiomatic Rust and you get like 1,000 times the performance improvement to Node. Maybe not that extreme, but you know what I'm getting at.
Yeah. All right, so let's move into the magical handler functions. Now, you took a look into this one.
Yes.
Tell me more about it.
So I think I'm keeping a really close eye on these guys. This lunatic. Let's have a look here. This lunatic. It's a funny name, I know.
Erlang is inspired, though. I've got a lot of respect for Erlang and their event-driven model.
Exactly, and that's what I think is so interesting, and where Rust doesn't force us into any runtime, it has essentially no runtime. It allows us to, if we want, we can have a Tokyo-style async await runtime, or we could have this Erlang-inspired runtime, which is there's no async await in this world. The runtime handles scheduling and enables for like massive concurrency. But what's really curious about it is it runs on WebAssembly, which has some really interesting properties, mostly being super lightweight. It has really good security. Like what it seems like WebAssembly has state-of-the-art security process isolation. So you could run untrusted code in this environment, and it would be completely locked down if you wanted it to be. So I think this could be a really interesting foundation for a web server, which they've announced here that they're working on. So they're working on this a server framework for this lunatic runtime. So that's the background of who these people are who have written this article. But this article is really interesting to me because I've been using the Axum web framework a lot recently, and this thing, there's no formal name for it, which this article says, but it appears quite magical how you write your handlers, your root handlers. You can, if we go to examples, explain what I mean. So we have this. We want to get some users when we hit this endpoint. We can do stuff like this. We can just say, I want to extract the query from the request. So I can just drop in this parameter, and somehow there's no ordering. So like you can see here, in the next root handler, I've got a completely different type for my parameters. So now here I'm extracting the database. I'm extracting some other data that's coming on the body of the request. And I was always so confused, like how this really feels magical. It's like the type signature is changing based on how I'm using it.
It seems like something you'd be more expecting to see in TypeScript or something, and more dynamic language.
Exactly. Yeah, it feels very dynamic. And the only way I thought that this, to me, let's just say this is magic. The only way you could achieve this would be by leaning on macros like Actix does, for example, which you can do similar things in Actix, but that needs a macro. And so this article basically explains how it does a good job actually of explaining how Axum does it. Turns out you just there's multiple implementations for a different number of arguments, and then if each as long as they all implement the from request trait, we can just invoke our so imagine this is like get users, and we just invoke it with the arguments here. So somehow the type it kind of moves the control flow into the type system. And this article says that that might not be a good thing, because all of a sudden now there are performance implications to this approach, because now, for example, here I want to take a reference to something from the request, and here I want to take ownership, so I'm not copying anything else. With this approach, I think the way it works, to see how they implement it here, that the last argument always takes ownership or something like that.
I see.
So it kind of forces you as a developer to, you no longer have control over how this is borrowed, how this data is passed around and borrowed. It also has implications on error handling. So now if let's say this payload coming in here doesn't adhere to the JSON that was sent here doesn't adhere to this type, this is going to reject before it delivers to us. So we need to figure out how to handle that. You can, this article does explain what happens when the extractor fails, and you can do things like implement, it kind of feels a bit long-winded in practice when you have to implement rejection states manually. And I've done it, but at the same time, it's kind of clear. This is a strange pattern. So I even said it by decorating. Like if we're in Java or Node, we would add decorators to offer this sort of functionality.
Yeah.
So here I want to say this route can only be accessed by admins, and all I have to do is drop in the type. And then if my request doesn't have this type in it, it won't execute.
It won't find a handler function, right?
Exactly.
Interesting.
And as this guy says, it gets a big no-no from the author, this pattern, because like, let's say in this admin function, I actually don't need anything in this parameter, but I need to do something that only admins can do. Later, I might put an underscore here to say, yeah, this isn't used, and someone will come along and delete this, and now all of a sudden I've lost the authorization on this endpoint.
Oh yeah, that's a good point.
So it's it's a little bit implicit, a little bit magical. The author talks about how Rust developers he expects don't like magic, and you can see
it's
that
definitely a loaded term.
Yeah, but then this approach is popular because of the flexibility and the dynamic nature of what you can achieve. But then what's really interesting is, despite saying this is an odd pattern, some of it gets a no-no. I think the sub-millisecond library does actually implement the this magic handler pattern because I guess it's kind of useful, because otherwise we just have to get the request every time.
Yeah, it's a trade-off, but it definitely provides value there. I still don't totally understand how it's working behind the scenes. I'm guessing it's creating the compiler is creating a static version of each handler function based on the type. So you'll have automatically generated static versions on all the types that you've ended up using it with at compile time. But I still haven't totally wrapped my head around how that works. I've dug into dynamic dispatch, but this is a little bit more performant. You don't have to do that reference table lookup on this style.
Yeah, exactly. There's no runtime cost to this abstraction because there's no dynamic dispatch. So you're absolutely right. So I think the way it is actually implemented probably is with macros, but it essentially compiles down before the runs, so when the macro compiles, it will produce something like this. So let's just say I want 3 arguments. You would add another generic here, and then you'd just call from request on that generic, and then you pass your function. You pass those arguments to the function that you created. It's kind of this is the thing with this sort of type level magic. Almost, it feels like it's a little bit hard to wrap your head around, and that has implications on how to reason about what's happening in your code.
It does, but it's also taking advantage of the sound type system, the soundness of the type system in a way that's really advantageous, I think, to make it easy to work with.
And you're right. Ultimately, when the code is finally compiled, all these generics will be turned into real implementations, like non-generic implementations of exactly what was written at the call site. What's that feature called?
I don't know. I can't remember.
Yeah, I can't remember either. Yeah, that feature of, I think C++ has it with templates where it compiles to a real version of the actual type that was used.
So going back to our previous article, Arthur Huliao says the best possible reason to do a rewrite is to solve an unsolvable problem in the current platform. And I definitely agree with that, but that's a rough situation to be in, where you've gone as far as you can with your current platform and you know you're going to have to rewrite or die. That's a stressful situation. All right, so I accidentally unshared my screen, so I have to add it back to the call here. There we go. So the next article I wanted to talk about is this article about different test scopes in Rust, all the crab pictures. I've got some AI-generated crab pictures that I've been using for stream bumpers and things like that.
Brilliant.
So the article here is written by Nicholas Frankel. He's a developer advocate with over 15 years of experience consulting for different customers in a wide range of contexts. His traditional specialty has been Java, but his recent posts, he's been focusing a lot on Rust. And this one talks about the problem of dependency injection in our testing. I won't spend a lot of time on this article. I'll try to get through it pretty quickly, but basically he talks about how in Java or Kotlin, how dependency injection would work and why this doesn't work in Rust, because it's a runtime thing. So the dependency injection that I've worked in other systems too has always been runtime. You mentioned Dagger too. I'm not familiar with that, but there is at least one other DI framework that's static, but not Rust. Rust is, and Rust is not object oriented also. So we can't take the exact same approach that we would in Java or Kotlin. But in my projects, if you've looked at my Rust example caster API that's out on GitHub, to solve this, I'm using ignore. So I'll have a test, and my really isolated unit tests that don't require any kind of external dependencies at all will have the ignored, or I'm sorry, we'll just have the test or Tokyo test, depending on if it's async or not. And so it runs with a standard cargo test. But then if I have an integration test that depends on, say, a Docker Compose formation running on my local machine or out in CI, for that, I'll add the ignore definition underneath that. That means when you run cargo test, it'll ignore this, but then you can pass the flag -- ignore to then run the ignored tests. So that's where my integration tests that have some external dependencies would happen. But
interesting.
It works well, but it's binary. It's either true or false. There's only two possible states, which is similar to the dilemma we have in our Go code base, which has the same limitation where our integration tests just have a Boolean flag, and actually our unit tests actually run along with our integration tests because we haven't found an easy way to exclude them. So he talks about a different approach with the CFG macro.
Mm-hmm.
And there's already one built-in way to use that, the CFG test, or down here a little further, I'll go down in a minute, but he'll talk about CFG not test, so you can, again, get that Boolean flag. This is probably more idiomatic than my ignore. He talks about using the CFG macro it has a bunch of built-in features, flags that you can use, but you can also add additional flags with Rust's feature foundation here. There it is. Yeah, cargo features that allow you to conditionally compile things. So you'll see it in reusable libraries a lot where people will say, okay, if you want to add the Postgres features, add that flag, that feature to your cargo.toml dependency definition, and it'll compile the Postgres support, but otherwise it'll leave it out because you don't need that dependency. You can use that along with testing as well by defining features. He goes into setting like feature unit, feature IT, which I don't know what IT would mean, feature prod, but this would be a good way of separating your test into different scopes. So I'll typically have 3 different layers of tests, my really low-level isolated unit tests that don't have any external dependencies, then my shallow integration tests that only depend on the Docker Compose formation, not any deployed resources out there, and then optionally, depending on your situation, a full end-to-end test scope that actually does depend on the deployed resources and often manages the flow through a front-end application as well. So something like Cypress that's interacting with a front-end app that will then interact with your API. Those are the kind of end-to-end tests that I feel like are most valuable, but they're also the most fragile and hard to write. So you've got to kind of reserve those to the critical path. But being able to separate it out like this seems really helpful.
Remind me, when you can have a tests directory, which is intended more for integration tests, and then you can also have tests next to the code for unit tests. When you run cargo test, can you decide not to run one or the other, or you have to run them both?
It runs them both. That was definitely something I struggled with early on because, I used that test folder for my integration test, but it kept running alongside the unit tests. And so I had to add that ignore definition in that case.
Yeah, interesting.
It seems like that would be an easy or a natural split point where you could say, okay, don't run those integration tests in the test folder, but I couldn't find a way to do it.
Yeah, I can't remember. I'll have to read about it again, but I think it's become, maybe it's just a convention to put integration tests in that test directory and co-locate your unit tests.
Well, no, it actually does change the behavior because it loads each Rust file in your test folder as a separate module, and you have to interact with the code that you're testing through the public interfaces exclusively. It doesn't give you private access, so it is a little bit different. Let's move on to the little joys of Proc Macros article. I'll just cover this one briefly, but I thought it was really interesting. You mentioned decorators earlier, and that's exactly what this post is talking about. So Felix is a computer science and programming enthusiast currently working for Neuroloop, which is a German neurosurgery tech startup, which sounds like a really fascinating domain to work in. He's using Warp, which is the same HTTP server I'm using right now. I may end up switching to Axum. You've definitely planted the seed
Axum
in my mind. But Warp is nice. It's created with Tokyo in mind first. It's built on top of Hyper by the Hyper is the Tokyo requests library. And I believe it's Sean what's his name? Sean Monster is his handle, but I think he built Hyper also, and he's a prolific contributor. But it's tricky. It has a functional approach that's not familiar to a lot of people that are coming into Rust, and some of the typing hoops that you have to jump through for filters can be a struggle at times.
I think that's what stopped me from using Warp is, although the functional paradigm I'm okay with, it's that block of code there, the nesting of brackets, it's more of a syntactic problem I have. It's harder to grok the inside out style, whereas in Haskell we have syntax sugar for dealing with these kind of pipelines.
Yeah, the bind operator and things like that. Monads. So he talks about working with the Anyhow library.
Oh, I love Anyhow.
Anyhow is amazing. Like, working with errors without Anyhow is so much harder, so much more verbose. It handles a lot for you. But he discovered that warp rejections are not compatible with the Anyhow error type or trait or whatever. And there was no easy way to convert them. So he talked about how in Python, he would write a decorator like we were talking about, which is something that I've used extensively back in the Python world. I loved the decorator syntax there. And we don't really have it in TypeScript, but we can still do the same thing by using higher order functions to wrap things. But he talks about how a proc macro is actually an interesting way to approach the same problem. And he links to a couple of articles to learn more about proc macros, but they take token streams, the arguments and the annotated function itself. And it kind of gives a way to wrap a function dynamically with a macro definition. And he's using it along with a couple of different libraries, this syncrate and quote crate libraries, to translate it into an abstract syntax tree and to then generate a return token stream for it. But you're basically modifying the code at compile time with the macro. So he's got his eat error macro there that will take the result that is returned, the anyhow result, and automatically convert that to a warp rejection using this token stream. So it's a little bit verbose. It's complex. It's definitely a lot harder to do something like this than it is in Python. Oh, but yes, I'm remembering the decorator support in TypeScript now. It does have some more low-level details that shows up in the function signature, but not quite to this level. This is definitely the most verbose way that I've seen, but you can still do it. That's amazing.
The other problem with proc macros, I believe, is you can't define them within the same crate that you're working in, same package. So let's say I have this problem in my app. I have to now create a separate library and turn my directory structure into a cargo workspace, define it in another file. I believe this is right. And then I have to import it over the library as a library rather than having it as a code within my same crate.
I keep my repos organized with workspaces anyway, because I've always had that structure of entry points and library code that I like to work with, no matter what language ecosystem I'm in. I use NX to do it in the TypeScript ecosystem, and in Go. Go just kind of naturally supports sub packages. So I'm already using workspaces, so that's not a big lift. But if you have a package that's not, that definitely adds a lot of overhead that you might not be expecting.
Yeah, the actual cargo manifest has to say proc macro true in it. So yeah, it's a minor problem because the workspace support is so good in Rust, but something that it's been enough in the past to stop me from writing it, for example.
That makes sense. definitely not as easy as decorators in other languages, but the soundness is often what places such restrictions on things, and the level of predictability that the type soundness gives you. Yes, it has to be exhaustive. Yes, you have to solve a lot of edge cases up front and reach into more complicated solutions like this, but it gives you so much more confidence in your code running. The meme of, if it compiles, it runs. It's not always true, but a lot of times it is, and that's worth the trade-off in my mind.
For sure.
All right, so we've got two more. This article, and then we'll plug a book that we're excited about. So this article, it's really an interesting series in general, called Platform Agnostic Drivers in Rust. And this specific entry is about publishing to crates.io. So I won't go into the platform agnostic drivers part, but I find it very fascinating. And if you look this up, definitely take the time to read some of the prior articles, because he talks about, okay, first off, how do you create a driver? How do you optimize the code for the driver? How do you make that platform agnostic using a hardware abstraction layer? Things like that I've been really fascinated by, but not actually had any direct experience yet with yet.
Me neither. Mm-hmm.
But it's especially important in embedded environments. A lot of times when you're working with an embedded runtime environment inside a device or internet connected object or something like that, you can't do things like use the standard library. You have to omit the standard library. You can't use a lot of the built-in hardware access patterns. And so conforming to a hardware abstraction layer is really important there, and I've never known how to do it, so that's fascinating. This particular article focuses on actually when you have your library ready, you're ready to share it with the world, and you want to publish it to crates.io. And so this is quite a bit simpler than the posts leading up to it, but I think it has more broad application. Anyone who's sharing an open source crate on crates.io should stop and think about the things that he points out here. So he talks first about documentation, and he says really the idea of this post is to highlight how important documentation is, but it's more than just comments. It goes beyond that. But the first place that you start with documentation is with your comments in the code, and there are two main ways to provide comments that will show up in the automatically generated documentation that he talks about how to generate in a moment. And then when you use this cargo doc command to generate it, it comes out just by default in this really clean web page format that you see out there on the published. So it looks exactly like how it comes out there. So I didn't know how easy it was. I knew this was possible, but I didn't realize that it was just a cargo command away. So that's pretty exciting. And also, he talks about the package metadata and the specifiers that you should pay attention to before you publish your package to crates.io. And then one gotcha that he called out that I didn't know about is that there is a 10 megabyte upload limit. So you might have to bring in the exclude field to prevent certain things from being included in the package that aren't needed to stay under that 10 megabyte limit. But I imagine not a lot of people run up against that.
Yeah, because I think although the binary might actually be, the resulting binary will be way larger than that, maybe.
Yeah, the source code itself, I think, rarely grows to that size, but on bigger packages, it probably would. And that's a incentive, I think, to break it up into smaller pieces at that point.
Yeah.
But then he talks about generating an API token on crates.io so that you can then upload your compiled package. And how to use cargo publish with the dry run and everything. These are all things that I was familiar with in other ecosystems like the NPM world, but I wasn't familiar with crates.io yet. So I appreciate this nice overview.
For the crates.io, the cargo CLI makes publishing via your CI/CD system as well really nice and easy. So again, in my Spotify project, I compile the code, and then when I cut a new Git tag release, it will compile it and publish it to crates.io, and it's really easy. It's kind of like npm publish. I think there's a lot of crossover there.
All right. So before we move to our last topic, we've got a question from Mehdi Boujid. I might have pronounced that incorrectly. I apologize if I did, but he says, "Can I ask which font you're using on VS Code?" And that's a fun one. I've shown my VS Code window a lot in previous live streams. I love fonts with ligatures.
Oh yeah.
I love how they make these special operators that we work with, especially in a language like Haskell, where you've got user-defined operators all over the place. But even in TypeScript and Rust, I love the ligatures because they make it easier to identify different tokens or operators like that. So I usually reach for Cascadia code on Microsoft environments, or Fira code alternatively. Thank you. I'm glad I pronounced it well. But yeah, Cascadia code, and then falling back to Fira code on my Linux environments is generally what I reach for.
I think I'm using Fira code. Yeah, I also love ligatures. I don't think I even won't use a terminal emulator if the terminal doesn't support ligatures.
Oh yeah. I don't think I've looked to see if Windows Terminal does. That's what I typically use when I'm on my WSL environment. That's good.
It does, yeah. Fira code, or maybe Haskell, I think, is another one I use. What theme are you using as well in your VS Code? Quite like it.
Well, thanks. It's called Tokyo Night. And I'm using it with the Monokai Pro icons.
I did buy the Dracula Pro.
That's a good one too,
which is really nice.
That has a legacy going all the way back to like Eclipse, doesn't it?
Yeah, I think so. Yeah.
And thank you, Mehdi. I appreciate the compliment there.
Oh, that's nice.
We'll keep it up.
Yeah, actually, I was going to say I watched your video yesterday. Did you do a stream yesterday?
Yeah, I finished out my WebSocket implementation.
Yeah, that was really interesting with Tungstenite. And I have done a little bit of WebSocket stuff, but not too much. It looked really cool.
Yeah, I think I pointed it out at the beginning of the video, but the full duplex nature of WebSockets, GraphQL subscriptions don't really take full advantage of that. So that's why I like to typically do event-driven communication outside of the GraphQL paradigm. But WebSockets are really awesome. And then WebRTC provides a lot of kind of alternative capabilities along the same vein, but with a lot more that you can do.
But also, probably we're going into the weeds now, but I've been really interested in server-sent events. It's this relatively new feature. It's like a more abstracted, simpler version of full duplex WebSockets. It's basically a one-way only, so the server sends to the client, but it's really, it suits a hypermedia-driven UI really nicely. So maybe there's more to come. We can talk about this another time.
Yeah, I definitely am interested in that. I've heard the term, but I didn't realize what it was.
Really powerful, simple abstraction. It's really great for the majority of apps that don't need the full duplex WebSocket connection.
Nice. All right, so the last thing I'll bring up is that Luke posted a celebration post on Reddit that his 0.2 production in Rust book is finally available in paperback format. So it's been out there available online to read for a while now, and he progressively posted chapters as he was working his way through it, and it's been a really helpful resource for a lot of people. I understand you've gotten a lot of value out of it, right?
Absolutely. I love this book. It's probably the best technical book, or at least the one I've enjoyed the most and use all the time. So I read it the first time cover to cover in like March 2020 maybe. So some of the chapters haven't come out yet, but it's not just about Rust as well. It gives you good groundings in authentication and how to structure tests, not language specific. But as far as picking up good patterns in Rust, it's such an amazing resource. Really recommend the book, and I have it open right now because I was doing stuff over the weekend. I constantly refer to it.
So, are you a physical paper book reader? Do you typically like to have them on the shelf behind you?
Typically, no. Well, yes. A technical book, I don't like a physical version. I think technical books, it's nice to copy and paste. It's nice to search mostly because I'm searching all the time. Whereas a physical book, a physical technical book, I don't like it so much.
I will admit to really liking flipping through sometimes. Like after I've read
Oh, really?
a technical book, after I've made my way through it, being able to flip to a certain chapter and try to find that one example that I was thinking of the other day. It is easier with a physical book in front of me. But
Interesting.
I most of the time don't pick up the physical versions. There are just a few books that I have that way, just because it is so much easier. And obviously with my comic book obsession, I don't have a lot of physical space for books. All right. Well, this has been a really awesome experience. I'm so glad that you joined me on the show today. Thank you for everyone who joined and watched and commented. I really appreciate the comments coming in. They really help us know that people are engaging and enjoying with what we're talking about, and gives us new topics to bring up. So I appreciate it. All right. Well, thank you very much, Alex. I'll go ahead and cut things off now, but I hope you have a great day, and hopefully I'll have you back again soon.
Brilliant. I'd love to.
Thanks a lot.
Take care.